Hi, my name is Nikhil Kokitkar. My today's topic is routing table structure and route calculation. So first point is routing overview. So what is routing? Routing is the process of selecting the best path for data to travel from a source device to destination device across one or more networks. It involves forwarding data packets based on the destination IP address using routing table and routing algorithms. So purpose of routing is network communication, data packet forwarding, optimizing network traffic, routing tables. So routers use routing tables which contains information about network paths and destinations to make routing decisions. So now uh, we'll see difference between static and dynamic routing. So according to path selection, in static routing one pre-configured route to destination, and in dynamic routing multiple available routes to destination. So there are number of points on which we can differentiate between static and dynamic routing, such as route updates, uh, route tables, protocols and algorithms, computation and bandwidth, security, and use cases. In next slide, we'll see a routing table. So what is routing table? Routing table is a data table stored in a router or network host that lists the route to specific network destination. So routing tables are essential for directing data packets from their source to their destination across a network, especially when the destination is on a different network segment. So this is the structure of routing table. So first of all we will see which parameters consists in routing table. So first one is network identifier, second one is metric, and third one is next hop. So in uh, in this slide there is one table which contains routing table example routing table contains. So we can see how routing table works. So the column network destination and net marks together describes the network destination, and the gateway column contains the same information as the next hop. The interface indicates the interface column indicates what locally available interface is responsible for reaching the gateway. In this example, gateway 192.168.0.1 can be reached through the local network card with address 192.168.0.100. Finally, the metric indicates the associated cost of using the indicated route. This is useful for determining the efficiency of a certain route from 2 points in a network. So this is the example routing table contents. In next slide we will see route calculation. So in route calculation, these are some parameters for route selection criteria, which is routes are selected based on criteria such as longest prefix match, where the most specific subnet mask is preferred. So these are some criteria on which route selection works. So first one is hop count. Hop count means number of routers a packet must pass through. Second one is bandwidth, which prefers for routes with higher bandwidth. Third one is latency, cost, reliability, load balancing, security, policy based routing. In next slide we will see one example scenario for route selection. So this is the example scenario for route selection. So in this, router A is connected to router B and C. Router B is also connected to router C. So scenario is a user at office A wants to send data to office B. So in this, route selection criteria is OSPF. OSPF uses cost as, as its primary criteria for route selection. So there available routes from A to B is, first one is direct route which is from A to B, which cost 10, and via C, A to C, C to B. So cost is 5 plus 2, 7. So even though there is a direct link from A to B, OSPF selects the second route because it has a lower total cost 7 compared to direct route 10. And in dynamic behavior we'll see that if the link between A and C fails, the routing protocol automatically updates the route to use the direct link A to B despite the higher cost, which ensures reliability. So our next point is routing algorithms. So routing uh, routing algorithms are essential components of networking that determines the optimal path for data packets to travel across a network. These algorithms are used in various types of networks such as computer network, telecommunication systems, and sensor networks. So some common routing algorithms are distance vector routing, link state routing, path vector routing, flooding, and random routing. So this image show how routing algorithm works. So our next point is how routing algorithm works. So these are some parameters on which routing algorithm works. So first one is network topology, routing tables, path selection, matrix. So in matrix, routing algorithm consider various metrics to determine best path such as distance, cost, reliability. So algorithm, there are different algorithm exist, each with its own approach to path selection, which is distance vector routing, link state routing, path vector routing, centralized and distributed routing. So in this way routing algorithm works. At last, understanding routing tables, dynamic protocols, and routing algorithm is essential for efficient network management and optimization. Each protocol and algorithm has its strengths and drawbacks, requiring careful selection based on network needs. Thank you.